week, it's not enough. Okay. Today is the 5th, I think, right? Okay. So what type of equation is this? Perfect. It is a rational equation. What do I have to do first when I solve a rational equation? Okay, that's one thing, but I also have to factor this and state restrictions. So when I copy 2x, I copy 2x over. Very good, awesome. 2 over x plus 2 is clear, and then excellent. So far, all steps are fine. Now I have to state 2 restrictions on the side, but you cannot just pick numbers and say, oh, 0 and 4 and 15. No. How do we get these restrictions? Where do they come from? The denominator is 0, exactly. You cannot just say x not equal 0. Why? Where does that come from? You cannot just list 15 different x values. I saw someone listed like 10 different values. Where do these come from? You only have to say that x plus 2 cannot equal 0 and x plus 4 cannot equal 0. So there are only 2 restrictions. There are only 2 different factors in the denominator. One that is x plus 4 and the other one is x plus 2. So there are only 2 restrictions. What are they then? Please, Ryan. Right, because when I write x plus 2 not equal 0 and I move 2, I would write x not equal negative 2. And the same thing for x plus 4. So the answer here for the second one is exactly, perfect. So I secured the restrictions because when I'm done with this problem and I get x equals 15 and x equals negative 2, for example, then I will say, oh, negative 2 cannot be a solution. And x equals 15 can be. So I secure this. Good. What will be the next step? Very good. This is what I do. Because if I omit this and this, I will change the equation to an expression and I will never solve. The least common denominator is? The least common denominator has to have all different factors we see here. I only see one factor, which is x plus 2, and a second factor that is x plus 4. There are no other factors. This must be the LCD. Good. Next. Right. So what if the denominator is this? Do I need to make any correction, adjustment? No. So I'm just going to say 1. Or not write anything. It's fine too. If this is x plus 2 and the least common denominator now is x plus 4 times x plus 2, what do I have to multiply the top by? X plus 4. And finally, if x plus 4 is the denominator here, but this is what I have in the denominator as a product, then what do I need to multiply the top by? Right. Are we all in agreement with this? You will not remember if you don't practice. You will not remember if you don't redo these problems at home. And examples in the book, and odd number problems, and homework, and. Good. So now, can anyone dictate the top? Good. Yes? Awesome. Do you all agree with the top? Do you all agree, everyone? Okay, perfect. So then, what will be the next step? Look how many different things I test with one little problem. First of all, if you identify it correctly. Secondly, if you find the restrictions correctly. Thirdly, if you find the least common denominator correctly. Fourth, if you correctly identify what everyone needs at the top. 5, if you know how to combine like terms. 6, how to change this into a proportion. 7, how to factor. 8, how to solve. 9, how to go back and check against the restrictions. A lot of steps and a lot of different things we test with one little problem. Okay, so my next step would be then, yes, and write everything in descending order. That's crucial. So what will be the descending order? And look here what I'm doing next. So I copy x plus 4, x plus 2. And now what will be the what will be the simplified form of the top in descending order? Perfect. Very good. Very good. Now this is a proportion. Only in a proportion I can do what I'm going to do next. What is that? Cross multiply. So then what do we get? Awesome. Do you all agree with this step? Now here is a very important statement. I'm going to ask you now, what type of equation is this, first of all, before I say what I wanted to say. What type of equation is it? It's no longer rational, right? The rational equation has to have x in the denominator. So exactly. This is a quadratic equation. This is a quadratic equation indeed. If you give me a quadratic equation and also polynomial, higher degree than 2. If you give me, let's stick with this now. If you give me a quadratic equation and you say to me, solve it. When I look at the equation and I see a negative leading coefficient, I said, no way. I'm not going to solve a quadratic equation with a negative leading coefficient, ever. I refuse to do that. So first, I will prepare it by multiplying it both sides by -1. So then I have x squared minus 2x minus 8 equals 0. This is the equation I want to solve. I will never, you can never force me to solve a quadratic equation with a negative leading coefficient. Because solving this one is like solving that one. I don't want to have to mess with a negative leading coefficient. Now, it's much easier to see that this is factorable, and I will be done in a blink. But I have to remember how to factor this. How do I factor this? Do we all agree with x minus 4 and x plus 2? Then you will agree with two possible solutions. What are they? Good. So x equals 4 and x equals -2. With both, now this is the final step. With both, I go back to my restrictions. And I make a decision. Yes or no? What is our decision then for this problem? For which one? For x equals -2 is a no. For x equals 4 is a yes. And I avoided going back to check solutions. But you can say, okay, you didn't check the solution, but what if you made a mistake somewhere down the road? It's possible. It is. But unlikely. Or the possibility is low. Okay. Any questions for me? Any questions? Okay, I'm going to try and finish 1.5. So let's go back to all those 4 methods. Yes, please. Yes. Yes, any question? Yes.
So on that last, you multiply everything by -1 and change it. Now, do you just do that to avoid problems, or because it will be?
Why would I factor with how will I factor with a negative leading coefficient?
I mean,
I have no idea how to factor with a negative leading coefficient.
So it just isn't logical. You would have to always make it.
Right. It's much easier. Yeah, it's much easier. I will not know how to factor with a negative leading coefficient. I would have to twist. Actually, I would have to twist this into 4 minus x in order to make it work. But there is no need to do that. It's an equation. I'm allowed to multiply both sides by whatever I want except 0. I'm allowed to divide both sides by whatever I want except 0. Because the solution will not change, or solutions will not change. Thank you. Very good question. Okay, so let's go back to I gave you a handout on factoring. If you have any difficulties with factoring, tell me anytime, because I see there are some difficulties with factoring. So I gave this document. So it goes through all possible, really all possible factoring situations. It gives you the special products for binomials, special products for, well, where they are, right here, special products for trinomials. And you have a lot of examples. They're not solved examples. And this is the strategy of factoring. Now, if you know how to factor binomials, trinomials, and polynomials, this is very straightforward. Now, I also want to say this. If a problem is asking us to factor, then we have to factor to solve it. But if the problem does not ask us which method to apply, if factoring takes more than 20 seconds, 30 seconds at the most, forget it and use another method for solving, okay? So if it's a binomial, you have to go through these steps, and these are the special products. If it's a trinomial, then these are special products, and these are two other methods. And if it's a polynomial, the only method is factoring by grouping. Why don't you look at this between now and Monday, and let's assign a couple of examples from here and work on them. And then on Monday you can say, I still need help on factoring. Okay? So from these, I would like to select part A, part B, part C, E, and F. So A, B, C, E, and F. From here, I would like to select A and B from the next section. From the last section here on this page, I would like to select B and D. So let me repeat. From the first section, A, B, C, E, and F. A, B, C, E, and F. On these problems, you can see the people in the math lab. You can come to see me, whatever it takes to figure this one out. In the second section of this handout, A and B. And in the bottom section, B and D. Now, on the back page, A and C at the top, and A and B in the last one. So A and C and A and B. I will also post this tonight with the lecture notes so you have that again. Okay? And from here, just choose one example, and one example that you would like to work on. One from here, one from here, one from here. Okay? And then we'll talk about it on Monday. So this is for Monday. Okay, so moving on to with taking square roots. So let's look at, let's say 26 on page 167. So we have x minus 1 squared equals -9. This is exactly what Ryan was asking. He said, okay, what if this side is a negative number? Can I still take the square root? The answer is yes. So we will solve the equation by taking square roots from both sides. I should write the absolute value of x minus 1. Instead, we just write x minus 1. And we will put plus or minus on the other side. But now I have to figure out what this is. And if you remember, the square root of -9 can be replaced by the square root of -1 multiplied by the square root of 9. If I have here a plus b, I cannot write the square root of a plus the square root of b. But if it's a product, I can break it up into a product of two radicals. But now we have to remember what this is. Does anyone remember what this equals to? Exactly, that is the I. The square root of -1 is the imaginary unit. Imaginary unit. And what is the square root of 9? 3. So what would be the answer for now? X minus 1 equals plus or minus 3i, indeed. However, I haven't solved for x. Now this is a linear equation. I have to do what is the last step here? X equals? Exactly. Perfect answer. However, we prefer presenting it like this. We prefer inserting the positive 1 in front of the plus or minus, not behind 3i. Is it an error? No. If you write plus or minus 3i plus 1, it's still fine. It's the correct answer. However, this is the correct presentation of the answer. Let's work on one more with taking square roots and then continue with the next method, which is completing the square. So I'm looking at 23 caught my eye on page 167, and that is 3x minus 4 squared equals 15. Now I want to point out something here. Look at this equation. Could I have used taking square roots in this equation to solve this for x? Why didn't I take the square roots on that one? And I took the square roots on this one.
Because on one on the top, it's not all one number.
Right. So it's the square is not completed.
It's just.
I have to have whatever with x in here squared, whatever it is, and the other side a number, right? So even if I move a to the other side, I don't have a quantity squared on your left, right? So this method is not applicable there. Okay? So in order to take the square roots from both sides, how does the equation, the quadratic equation, have to look like? It has to look like something squared with x in it and a number on the other side. Otherwise, the method of taking square roots is not applicable. So now, look at this one. Can I apply taking square roots? You should say yes, but there is an additional step that you have to perform. What is the additional step that I have to perform? I have to divide both sides by 3. I have to clear and the 3 from there. So you will hear me say a lot, clean this up. It's an easy way of saying, or for me, it's an easy way to remind you, or say, well, it's not ready for what we're trying to do yet. Clean it up first. So yes, we will divide both sides by 3. I want to make sure that you never think of distributing 3 inside. That's not possible. By the order of operations, you have to square first and then multiply. So do not ever attempt to put 3 inside. So once I divide both sides, I get x minus 4 squared equals 5. Now, again, can I apply taking square roots from both sides? And the answer is yes. So the left-hand side and the right-hand side are ready. I have something squared with x on the left and a number on the right. Positive, negative, or 0, it doesn't matter. So the left-hand side would be, what will I write? I should write, the correct answer is the absolute value of x minus 4. Instead of that, I would write, and now because instead of writing the absolute value, I did not write the absolute value, then I have to put something on the other side. Plus or minus. And the final step would be, yes, to move 4, and I will move it right here. It was negative on this side. When I move it to the other side, it becomes positive. So that's why it's positive 4 plus or minus the square root of 5. And this is the final answer. Now the third method is the method of completing the square. I will be honest and say this. This method is very useful, but not for solving equations, quadratic equations. It's not. It's a very useful method for something else that follows in this course that we will be using it for. However, it can be used in solving quadratic equations. Also, I have to say one other thing. It alone will not solve the equation. So completing the square alone will not solve the quadratic equation. We have to use another method on top of it. And you will see which one. You will tell me which one. But we studied the method for something else. So bear with me. I'm going to pick a problem from your text. Let's say I'm going to pick 54 on page 167. And the problem is x squared plus 6x minus 5 equals 0. Now, when we started last week, if you remember, I'm trying to find one handout that we filled out. I can go back to the notes in the website, in Canvas. But I hope I have another copy here. If not, it's okay. If you remember, the first thing we did, we kind of signed an agreement, right? And we said the agreement will never expire, and this is the agreement concerning 3 special products, and we have to commit them to memory forever. Do you remember that? And here it is. I'm going back. That was the very first thing we did. That was last Monday. This was it. So binomial squared is a what? No cell phones, please. A trinomial. And if it's a sum, we have a sum in the middle. If it's a difference, we have a difference in the middle. And we also have the special product of difference of squares. So these 3 are on this handout. So you already, for a second, so you already have the first one here. We discussed it in the agreement. And you have these 2 here. So the first one and these 2 are already discussed last Monday. Okay, good. So knowing this, you will see that when I square a binomial, right, the first term is the square of this. The middle term is 2 times the first times the second. And there is also some third term. Why do I need this? You'll see in a moment. Here it is. Now, I'm going to say disregard the -5 and the equal symbol and 0. And let's analyze what will the third term be for that. So I have to add a third term to both sides. I cannot add to one side of the equation and not the other. And I would like you to tell me this plus this plus this will yield something squared. So keep in mind, whatever I have here, the sign has to be what? The sign has to be positive. And then I need to have a second term such that the first term squared is this, plus 2 times the first times the second is this, plus the second term squared, that is this number that I have to add to both sides. So obviously the first term must be, what do you think? So that when I square it, I get this. Yes. Perfect. That must be the case. Then since the middle term is positive, obviously positive. And now let's think. What should I have in here so that I say to myself, 2 times this times whatever is this? What could it be? Please, Ryan.
3.
It has to be 3. It must be 3. Do we agree with that? So the first term squared is x squared plus 2. That's why I refreshed your memory on the first day of classes. This will follow us everywhere we go. So the first term squared plus 2 times the first times the second, plus the second term squared, which I have to add to both sides. Which is that term that I have to add to both sides? Okay, let's do this one more time. First term squared plus 2 times the first times the second plus the second term squared. What do you think?
9.
That's it. This is the number that I need, and that will help us complete the square of this, this, and this. But I need it on both sides. I cannot just choose to add it to one side and not the other, right?
So the term that you're always adding to both sides is the middle term.
Divided by 2. Yes, I'm going to put this shortcut in a minute. Yes, exactly. So yes, what I have to add to both sides, Ryan is correct. He said this. Take 6, divided by 2, you get 3, square 3, and this is the number you have to add to both sides. Correct. But I want you to see where it's coming from first. And then, yes, I will write the... Okay, so can anyone dictate the new equation now? And there is a trap here. Here's the trap, and I don't want you to fall into it. If you add 9 to negative 5 and you say it's 4, you're not going to complete the square. You cannot do anything with this unless, if you want, right now, move it to the other side. The negative 5 is not a useful number for what we're trying to do. Good. So please dictate a new equation. Not the completed square yet. Not yet. So x squared is x squared plus.
6x.
Very good. Plus.
9.
Exactly. Equals.
14.
Yes. I'm going to write it 5 plus 9 for everyone to see, but it's 14 indeed. And I have to look for my little tent. Please. Okay. Very good. So now the left-hand side is a perfect square, which is, one more time,
X minus 3 plus 3.
everything squared. The right-hand side is 14. Okay. So after all this effort, and I will put the method in writing the shortcut in a second. After all this effort, what did I accomplish? And you can say not much, and I'll have to agree. So I changed the equation from x squared plus 6x minus 5 equals 0 into the equation x plus 3 squared equals 14. And now what? This doesn't solve the equation. But I have a method that I just finished talking about, which is,
Squared.
yes. So as you see, completing the square is kind of useless for solving quadratic equations, because it alone cannot do the job. However, it's a method that we need to know for something else. And now I go back, and all I have to do is write that x plus 3. It should be the absolute value. Instead of writing the absolute value on x plus 3, what do I write? Plus or minus the square root of 14. And then I have to move 3. And when I move 3, I finally get the final answer to be,
3 plus or minus.
careful, it was positive here. Very good, negative 3. My 10 just fell.
Do we ever have to simplify the
Yes, but in this case, it's 14.
Okay.
Yes, of course. We will have to simplify, but not the square root of 14. Very good. So now let's look at a different example, and now I will present the shortcut. Look at that. Sorry. Okay. Now let me pick another problem. Of course, they can get more difficult. So I'm going to pick one, let's say 58. And x squared minus 3x minus 5 equals 0. And as Ryan suggested, he was right. The first step is identify. So this is for complete the square. Identify the middle coefficient. Can anyone identify the middle coefficient for us? Step 2. divide it by 2. Why do I divide by 2? For the reason of that 2 from when we squared a binomial. So then I have negative 3 over 2. Step number 3 is square negative 3 over 2. When I square negative 3 halves, what do I get? Remember, I have to square the top and I have to square the bottom. So when I square negative 3 at the top, or a negative number squared is positive, and when I square 3, I get, and when I square 2, I get, and final step, add 9/4 to both sides. And complete the square, of course. Not just add and forget about it, but add and complete the square. I recommend from the very beginning, move the negative 5 to the other side. So then the new equation becomes x squared minus 3x, very good, plus 9 over 4 equals, remember this is absolutely crucial. We're not allowed to add to a balance. Look, I have a balance here, same weight, assuming that they're exactly the same. I cannot just say, okay, this is the same. No, it's not going to be the same. So if I add 9/4 to one side, I must add 9/4 to the other. And now, this should give us no difficulty. We know that that is a perfect square. We made it so. We determined 9/4 so that it is a perfect square. So can anyone tell us what it is? So it has to be x. You're correct. It has to be minus. But careful now. Whatever I squared here to get this is the number I need. Remember, the first term squared is this, minus 2 times the first times the second is this, plus the second term squared must be this. Very easy to remember, right? So what is it? Exactly. It's the number that I squared to get 9/4. That's how we got 9/4. Now the right-hand side is an addition of two fractions. What do I have to find first? Yes, the least common denominator. Well, actually, there is only one denominator. But remember, I cannot just say 5 plus 9. I need the adjustment, something that 5 needs to be multiplied by, because 5 had denominator 1, and all of a sudden we have 4, which means we multiplied 1 by 4. I have to do the same thing to the top. What am I multiplying 5 by then? 4. 4 times 5 is, so let's write it for everyone to see, 20 plus 9. So this is x minus 3/2 squared equals 29 over 4. Okay, that's perfect. But I haven't finished. And I can't. I worked so hard to complete the square. Now what? How do I complete this? Yeah. I have no choice. So then what will the left-hand side be? Very good. And the right-hand side, I can never forget. How many solutions do I have? All quadratic equations have. Exactly how many? 2. If I omit the plus or minus, I only get 1. So I have to write plus or minus. I cannot take the square from 29 as a prime number, but I can take the square root of 4, and I get, what will be the very, very last step? Yes. And that's the end of it. So the x equals 3/2 plus or minus the square root of 29 over 2. The method is important, and the method is not too difficult, but requires a lot of practice. So make sure you do, so we can talk about more problems next time. And the last one is quadratic formula. So this was method 4. And quadratic formula, first of all, the equation, the quadratic equation, must be in this form. We have to have 0 on one side. We have to have everything in descending order. on the other side. If the equation is not presented like this, I cannot use the quadratic formula. Assuming the equation is presented like this, then x will be negative b plus or minus the square root of b squared minus 4ac divided by 2a. Again, like with the previous, in the previous lecture on the 27th, when I said just repeat those three special products, creating yourself a tune, the same thing here. Negative b plus or minus the square root of b squared minus 4ac over 2a. So repeat it and repeat it and repeat it. So let's look at one problem, like, for example, 80, just to solve it, on page 167. So this is 3x squared equals 2x minus 1. Okay, so we're asked for this problem, we are asked to find the discriminant. I'll explain what that means in a second, but I'm more interested in solving it using the quadratic formula, and then I'll explain the rest. What is the first step that I have to perform here? Because I cannot use the quadratic formula unless the equation is presented as, yes. So the left-hand side would be, and it has to be in descending order. Very good. Perfect. Do we agree or do we understand this? Any questions for me? Any questions? Okay. So now I do have A, I do have B, I do have C. That's my next step, to identify them. And I have to make sure that the numbers are taken with a sign in front. You cannot say that B is 2. B is negative 2. So A is 3, B is negative 2, and C is positive 1. All I have to do is just plug them in. So I have x equals negative B is negative negative 2, which is positive 2, plus or minus the square root of. Remember one thing. This number has to be positive, no matter what B is. B can be anything you want on the planet. The answer has to be a positive number for B squared. Do not ever write negative something here. There will be a mistake. So negative 4 squared is 4. Minus 4 times A times C, I'm not going to bother with writing times 1, over 2 times A, which is 6. So x equals 2 plus or minus. What I would like to do here under the square root, because it's easier than going back and simplify, it doesn't matter, it's up to you. From these two terms, I would like to factor out 4. What is left in parentheses is if I factor out 4 from 4, what is left? 1. Then minus. From 4 times 3, if I factor out 4, what is left? I took 4 outside. So what is left? 3 divided by 6. You'll see in a minute why I did this. So x equals 2 plus or minus. How much is the square root of 4? Because I'm allowed to split it now. So this will be the square root of 4 multiplied by the square root of negative 2. Because 1 minus 3 is negative 2. So the square root of 4 is 2. And what can you say about the square root of negative 2? Yes. So it's the same with the square root of negative 1 times the square root of 2. Which is I, the square root of 2, divided by 6. Now you can say, okay, fine. Why didn't you just do 4 minus 12, which is negative 8? Well, I can, but then I still get the same thing. But I have to split negative 8 then. But it's up to you. I do have to simplify. This will be a terrible mistake to do. To simplify, let's say, this 2 with this 6, or this 2 with this 6, there will be a terrible mistake. Because 2 and 2 here are part of terms. You cannot simplify a part of a term with a factor. You have two options. You either factor out 2 and simplify, which is allowed, or the other option is to write x equals 2 over 6, 2 over 6, plus or minus 2i the square root of 2 over 6. And now we can simplify each fraction by itself. 2 over 6 becomes 1/3, 2 over 6 becomes 1/3. But you cannot simplify a term with a factor, a term with a factor, or a piece of a term with a factor. That will not be allowed. So the simplified form is 1/3 plus or minus I the square root of 2 over 3. Because I'm simplifying 2/6 into 1/3 and 2/6 into 1/3. Now, I know that you have seen this before, quadratic formula, correct? Any questions on the quadratic formula? Any questions on the quadratic formula? Okay. Let's take a look at 1.6, other types.
What is
Yes?
the quadratic formula? What is the other 1 over 3? Never mind, the 2 cancels out.
Yes. So what I did was I changed 2 over 6 into 1/3 and 2 over 6 into 1/3. I just don't want my students to do this. That would be terrible. So the other option would be, let me write it here. So you can factor out the 2. So x equals 2 in parentheses, 1 plus or minus I the square root of 2. 2 times 1 is 2. 2 times I the square root of 2 is 2I the square root of 2. And now we are allowed to simplify, which will give us the same answer. But I cannot simplify in a sum. I cannot simplify 2 with 6 or 2 with 6. You either factor from the the top two terms, which is they have a common factor of 2, and you simplify, or you separate the fraction. Both are legitimate operations. Here I separate the fraction. I said a plus b over c is a over c plus b over c. If you prefer this, it's fine. If you prefer this, it's fine too. The answer is the same. Is this okay? Other questions? Okay, so other types of equations, and one of them is polynomial equations. And you can say, wait a minute, didn't we have linear? Didn't we have quadratic? Isn't that good enough? It is. However, we do have other types of polynomial equations, higher degree. I'm going to pick first one, number 2. And this is on page 185. So 5x to the 4th minus 20x squared equals 0. Like before, my first step is to do what? I'm given an equation. You give me this equation. What do you think will go through my mind first? Of course, because they all have different recipes, different methods. Perfect. Okay, so I'm looking at the left-hand side and I say, I see a polynomial. What is the degree of this polynomial? 4, degree 4. If the degree is 4, so it's a polynomial equation. If the degree is 4, how many solutions do I have to write, no matter what? Exactly 4 solutions. Mandatory. Mandatory. If the degree is 4, mandatory 4 solutions. They may be real, they may be imaginary, I don't care. 4 solutions. Perfect. Now I go back and look at the polynomial and the equation as a whole, and I say, oh, can I divide both sides by something? Can I make it simpler? Remember the cleaning up step. Clean it up if you can. And what will I clean it up with? If it's possible, if I can make it simple. And if I can clean it up, how do I do it? I will divide both sides by. Okay, yes, Ryan? You wanted to say 5. Okay, why not x squared? I can simplify by 5, but why I cannot divide by x squared? Because, first of all, if I divide by x squared, how many solutions will I find?
2.
Only 2. And what did we just write? 4 solutions. So here's a note for us to write. Note. Never divide both sides of an equation by the what? The variable. Never divide both sides of any equation by the variable. In any form. If it's x or if it's x squared or if it's x plus 5 or x minus 3, doesn't matter. We cannot divide both sides by the variable in any form. Good. So I divide both sides by 5. I can. It's not going to change the solutions, but it cleans up the equation. I divide 5x to the 4th by 5. I get x to the 4th. I divide negative 20x squared by 5. I get negative 4x squared. And I divide 0 by 5, and I get perfect. So now my next step is there a way of factoring this? And the answer is yes. What will I factor out? Factoring out is allowed. Whatever, because the factor will not go away. So what do I factor out? For sure. What is common to these two? That's it. What is left in parentheses? Very good. I want to continue factoring. X squared, and in parentheses, I have to remember what this is. We refreshed our memory on the first day of classes. How do I factor x squared minus 4? It's one of the 3 special products. And now I want to see 4 solutions. Some of them may be the same. So let's start with this one. What solution do I get from here? Let's continue with this one. What solution do I get from here? Perfect. And now, what solution do I get from here?
0.
Exactly. How many times? Twice. X squared is x times x. I have 4 factors. X, x, x plus 2, x minus 2. You will see what happens in the next chapter. In chapter 3, not in 2. In chapter 3, well, this is a double solution. Very important. Please commit this to memory, that some equations may have double or triple or quadruple solutions. And something very important will happen with their graph at that point. You will see that later. So I solved the 4th degree polynomial equation. I presented 4 solutions, although 2 of them were the same. That's fine. So I had x equals 0 twice, x equals negative 2, and x equals 2. Yes, please.
So if we wrote out the answer, we would have to specify that x is 0 twice.
No, but you have to show 4 solutions somehow, just to make sure, to show me that you know that a polynomial equation degree 4 has 4 solutions, and
So
you will
like-
see how important this is later.
So like we would state the
Degree.
restrictions on the other one, we would state the degree
Right.
on this one.
Yes, this one will not have restrictions, but I understand what you mean. Yes, it's just a step. Yes, exactly. So for the rational equations, you state restrictions because you know you cannot accept anything, just anything as a solution. And here, just for you to remember and not forget, in other words, degree 4, 4 solutions. Yes, please.
That's
Yes, very good. Okay, moving on. We have another type. Again, we need a lot of work on this. So I'm hoping that you are going to, we're going to talk in a minute. You're going to practice this. So the next step would be a radical equation. So let's say problem 20. I should have not said that. I should have asked you what it is. So you didn't hear anything. So it's the square root of 2x plus 15 minus 6 equals x. Now I'm going to smile nicely and say, what type of equation do you think this is? Yes. Totally different recipe. Let's refresh our memory on a few equations that we looked at. Linear. In linear equation, I want to separate the variable from the rest, right? Quadratic, depending which method I use from 4. Factor, taking square roots, complete the square, or quadratic formula. Totally different recipe, right? Rational, totally different method. Now this, radical, totally different method, okay? So once I identify it, I'm hoping I identify it correctly, then I would be able to go through the steps correctly. I'm hoping, right? So what do you think this, you already told me what it is, but what do you think will be the first step here? It's okay if you don't remember.
6.
Yes, I have to separate the radical from the rest. Exactly. So the square root of 2x plus 15, and I will write it as x plus 6. And you can say, sometimes you put that 6 in front, sometimes it follows. Yes, it follows because it follows an x. Okay, good. So now I want to apply a mechanism to both sides that eliminates this symbol. What mechanism applied to both sides will eliminate the square root? Exactly. So let me ask you this, which I didn't say a minute ago. Why do you think I take the square root from both sides here and not apply the cube root? I want to apply the cube root. I want to apply the cube root here and the cube root here. How come? Then I'm using the square root, or not the fourth root.
This doesn't cancel.
Because of this, exactly. In order to undo power 2, I have to use the square root. What if I had power 3 here? The square root will not work. The cube root will work. For the same reason why, when I want to get rid of the power 1/2, so the square root of 3 is the same with 3 raised to 1/2. 1 over 2. So when I want to undo power 1/2, I must do what to both sides? Square. I caution you on something extremely important. You cannot square term by term. Okay, I'm going to square this, I'm going to square x, and I'm going to square 6. No, it doesn't work like that. It's a very important step. So let's look at this example. Is 1 plus 3 4? Do you think that if I square this, because I like to square in this way, do you think that this is a true statement? Of course not. Because this is 1 plus 9 and this is 16. So this shows that I can square, but as long as I square the left-hand side as 1 unit and the right-hand side as 1 unit, then I'm in good shape. Because 1 plus 3, I have to perform the inside first by the order of operations. So 4 squared will equal 4 squared. But you cannot just say, I'm going to square this, I'm going to square this, and I'm going to square this. It's not going to work. The left-hand side is 1 unit, and the right-hand side is 1 unit. Perfect. So now the left-hand side, what do I get when I square the square root? That's it. That's why we squared, to eliminate the square root. But now the other side, I have to be careful, because this is our agreement from day one. How many terms will you give me? Aha, I want to see those 3 terms. Anyone? Other than Ryan. Yes? Awesome. Do we all agree with x squared plus 12x plus 36? Here's how we did that. Remember? First term squared plus 2 times the first times the second plus the second term squared. Awesome. Now I got into a different issue. What is this? What type of, yes. How do I solve a quadratic equation now? I must, in this case, it's not completed. The square is not completed. I'm not going to use complete the square unless you force me to. So I have the other options are either factoring or quadratic formula. But what do I have to do first? Exactly. Clean it up. Clean it up. So I have x squared. I will bring a negative 2x, and I will bring a negative 15. And you can put 0 on this side, or you can put 0 on that side. It doesn't matter. So I have x squared. I have 12x, but I'm bringing over a negative 2x. So what do I get? Plus 10x. I have a 36, but I'm bringing over a negative 15. What do I have now? So now I have 4 options, and you can say not that fast, not so fast. What are the 4 options? Because it's quadratic. Factoring. I like that if it takes very short amount of time. Taking square roots? No, it's not set up for that. I can't. Complete the square? Never, unless you force me to. And the last one is quadratic formula. So if it takes more than 20 seconds to factor, forget it. Quadratic formula. Which one? Does it take more than 20 seconds to factor this? So how do I factor it then? Very good. So I have 2 options. What are those options? Now, part of the problem, and there is no way around it, must check prospect solutions. Solutions. This is part of the problem, like stating restrictions for rational. Okay? This is part of the problem. I have no choice. Okay, so I go back to the original problem. I copy it here, 2x plus 15 minus 6 equals x. And I replace x by negative 7 and see what I get. Let's do this together. 2 times negative 7 is negative 14. Negative 14 plus 15, 1. The square root of 1. 1 minus 6, negative 5. The other side is negative 7. Will you accept negative 7 or say absolutely no way? So one more time. So negative 14 plus 15 is 1. 1 minus 6 is negative 5. Is negative 5 the same with negative 7? Absolutely unacceptable. Negative 7 is called, x equals negative 7 is called extraneous solution. Unacceptable. Correct algebraically because we got it from taking square roots, but incorrect for the original problem. And that's what we care about. We care about the original problem. Okay, now I have to check negative 3. So let's check negative 3. Let's do it together. 2 times negative 3. Negative 6 plus 15. Square root of 9. 3 minus 6. Would I accept x equals negative 3? Yes. This is the only solution The equation has only one solution. One of them was extraneous, was a byproduct that doesn't work in the original problem. It was obtained from squaring both sides. Any questions about radical equations? Anything else? Okay, I'd like to move on to equations with rational exponents. I only have 2 minutes left. Wow. I talk too much. Okay. I will not have time to solve that in 2 minutes. So, okay, let's look at the absolute value equations. Absolute value equations. That we can do in 2 minutes. So let's say 65, and then we stop on 186. And this is the absolute value of 2x minus 1 equals 5. If you remember the absolute value of 2x minus 5 equals 5, or let's say the simplest possible, the absolute value of x, let's say, equals 2, this is really asking us to find the numbers whose distance from 0 is 2 units. 0 is here, 2 units away from 0. What solutions will those be? Right. In the same way, so x equals 2 and x equals negative 2. In the same way, we have 2 options here, but this time not for x, but for what is inside the absolute value. So now 2x minus 1 has 2 options. What are those 2 options? What are those 2 options? What could I have here for this to work? This could be either
+1 or -1.
5. This could be either 5, so that the absolute value of 5 is 5. Or what could I have in here? What is the other option? That's it. That's all I have to write. 2x minus 1 can be 5, and 2x minus 1 can be negative 5. And then I solve for x. So please finish that up and give me the